So, in types of analytics that describes the past answer, basically in this section, we are having for our historical data set. To that historical data, we will try to answer the common question, that is, what has happened in past. And in order to do that, we apply the methods of descriptive analytics, which is basically divided itself into, let's say, exploratory data analysis, EDA, then exploratory data analysis. Along with that, we are having methods of what you will observe, data visualization is done. Then we'll have statistical analysis. So when you are just applying methods of visualization or statistical analysis, this will gonna be answering me the question of what has happened in past. This has got the methods of data aggregation. What are data aggregation methods? Data aggregation methods include sum, average, group by. These are your methods of data aggregation, and combined together it gives us the descriptive analytics. This is first type of analytics that you can perform on any of the data. Second, predictive analytics. Predictive analytics includes things of your machine learning, deep learning, that you basically apply to your available algorithm, to your available data. So these are commonly also called as statistical model, and also the data can be of time series type. So in that, you will apply techniques of forecasting. So you apply forecast techniques, or you apply the statistical model. When you apply all this, basically what you try to answer is, the type of question that you try to answer is, what might happen in future. So to your available data, you apply machine learning, deep learning, or time series forecasting. These methods are applied to apply the predictive analytics on top of my data set, and we try to get the answer of what might happen in future. Or and the last method is prescriptive. This is like a solution builder. You had a certain problem and now you are looking for some solution, so you try to build some solution here with the help of prescriptive analytics. So in this case, we basically go for simulation algorithm and some optimization algorithm. This is not the please do not misunderstood this as optimization techniques of algorithm. That is a different thing. This is optimization algorithms, which basically optimizes the solution for you. This has to be not misunderstood as topics of optimization techniques to make your performance of the model better. That is a different thing. Let's move ahead. What is now this? Let's go ahead. What is machine learning? The capability of artificial intelligence system to learn by extracting patterns. So first, let's get the definition of machine learning. Actually, I'll start from this analogy. So how we will define machine learning analogy? To start with a machine learning analogy, assume that there is a foodie person, and to that foodie person, I am asking a certain question. Can you recognize this image? If I'm asking this question of can you recognize this image, I should be expecting the answer. And here, to get the answer, this foodie person has got two things. This is already naturally trained, and it does have some past knowledge. It has got some knowledge already. This foodie person has got natural intelligence to answer the. So we have got knowledge and we have got natural intelligence both to these foodie person, and now I like to get the answer for recognize this image. How this foodie person is able to answer it? Due to the help of these two concepts, and the same is true for the machine learning as well. In machine learning, you need to that has to need a or gain knowledge, and it also will be using some concept of artificial intelligence. Proceeding ahead to that example, this is a two-step process. Step number one is training process. Say I wanted to teach this person about recognition of the different shapes. What I'll do, I'll be basically giving this particular person some shapes, and these different images I will show them as an input, and I will tag that, okay, if this is the shape you see, a circular shape with multiple slices, the output will be, so not only input, but I have to teach that what is the exact output for this. The exact output will be that it is a shape of a pizza. Similarly, we can teach this person about other things as well. Let's say this type of shape, and we will say that, okay, if you see this type of shape, then tag this with a target which is burger. Similarly, we can also teach them about different images. So basically, what I wanted to discuss here is that initially in the training stage, you need to teach this person about, which is basically an untrained human brain, zero knowledge about, let's say this is a kid who doesn't understand, has never seen how a pizza looks like or how different images will look like. So you need to give them the input as well as you need to take them with the output. Once you start doing it, what will happen? Slowly and steadily, this human being from an untrained human brain will convert into a trained human brain. To check the efficiency, you can feed them some new input data or new input images, and if this trained human brain is successfully able to predict or give you the successful output, then you can say that the model performance was good, or the trained brain has started giving you correct prediction with an untrained images, and you tag those images with the certain output. This is how the process will continue, and then you will test it by letting them predict for the new and unknown. In this case, we will talk about the images. Images is one of the example. It could be easily replaced by types of data as well. Now let's go to the next part. Now replace the human brain by a machine. A machine will not have a natural intelligence. If the same thing of recognition of the image, I wanted to teach that same thing with a machine, so it will look like this. That we will have a naive machine, or you can say that it is an untrained. Okay, a naive machine is there, which is already again unaware about what is this shape and what is this particular concept. And if somehow I wanted to solve and I wanted to teach this about recognize this image, if I wanted to do that, the same I wanted to do with the machine, I will take the help of concept of your machine learning. So how does it work? Again, two-step process. In the training phase, you will feed the inputs and the basically here we are taking an example of supervised learning, in that you not only just feed the input data but also you feed the output data. This f of x is nothing but it is a chosen statistical function. In simple terms, this is f of x is your chosen machine learning or deep learning algorithm. Chosen machine learning or deep learning algorithm. So when you will feed the input and the old output to your f of x, what will happen? Your machine learning will start gaining the knowledge, and this is how it will learn the hidden parameters. And once it has trained itself, it will be considered as an algorithm. Until unless it is not trained, it won't be able to make any predictions. So remember this thing, that every chosen statistical function needs to go through this process of training. If we are talking about the concept of machine learning and deep learning, it applies to both. So once it has trained itself, then the second phase is quite important. We need to validate it, we need to test it or validate it. Here in this phase, we will measure the performances for the new, you will just say new data. You will feed that to your already trained statistical algorithm. Remember, this f of x is the same, the one which we have used it. So first it has to go through the training, and once it has finished its training, it will be called as a trained statistical function. You can say that it is a trained statistical function. Now this function is ready to make prediction. We will compare if the predicted output is correct or not. If it is giving you the predicted output correctly, you have to check the accuracy, you have to check the performances, you have to check the performance accuracy. If the prediction is quite good, if the accuracy of the overall predictions are quite high, you will say that your model is ready to be used as a product or as an application for the greater goods. Okay, this is how the basic concept of all your machine learning and deep learning is. Let's take a quick definition. What is machine learning? Machine learning is a subset of artificial intelligence that involves the development of self-learning algorithms to gain the knowledge from the data in order to make. Okay, there are some concepts here. First of all, machine learning is subset of AI. It is one of those algorithms which does perform self-learning, and with that, it gains the knowledge from the data. Instead of requiring a coder will manually derive the rules from the data set, what machine learning do is it replaces the human being or the coders use, and what it expects is that you only feed the data and the output, the target output, your machine learning algorithm, and it will return you as an output the rules. Basically, these rules are used as a parameter to make predictions. If the predictions are correct or not, it will be based upon. So the condition statements are getting created by the machine learning in itself. You don't have to do it. It is that's the reason why it is called as self learning. So it learns from the data itself that what are the rules that we need to define in order to make correct predictions. This is one of those algorithms which makes data driven decisions. It makes data driven decisions here, as you observe. Now moving to the next, that's the definition. Hope you have understood it. Can we have a quick confirmation if the definition until now everything is clear? Artificial intelligence, how AI is different from machine learning. First of all, the definition says everything. In machine learning and in machine learning, I use the concepts like self learning technique, decision, and also I said that the rules and the rules will be automatically created, performed by the machine learning. So there is no external human intervention is not required. It gains the knowledge from the data. So this is one of those algorithms which are data driven, which makes data driven decisions. Moving to the next concept of AI, artificial intelligence is a branch of computer science dedicated to creating intelligent machine that work and react like human brain. So AI is a branch of computer science dedicated to create intelligent machines. Basically, try to make decisions just like a human being. That's the first thing. Artificial intelligence mimic human or animal intelligence. Artificial intelligence mimics human or animal intelligence to make decisions, and these decisions are just like the way human makes a decision. What type of problem statements you solve in this? Those problem statements which has to be actually earlier was made by human being, like answering somebody's question, then write a program. Nowadays the chat gpt is doing what? It is basically giving you not only the answers but also it is writing the whole program for you. That's an application of your AI. So basically it is making decisions on behalf of wherever making decision concepts come, that will be an example or application of artificial intelligence, like your self-driving car. Driving a car earlier was made by, I mean, it was something which has to be done by the human being, correct? You decide when to apply the accelerator and when to speed up and when to turn left, when to turn right, etc., etc. But when we talk about the concept of self-driving car, here the decisions are made by your neural nets. The next concept that we need to also discuss here about my artificial intelligence is that, okay, let's take another applications. As I said, chat gpt will be another application of your AI and many more. Obviously, the robot. Okay, now go ahead and let's compare where exactly your deep learning exists. So this picture says a lot. Artificial intelligence is the bigger subset, and your machine learning and deep learning are these subsets of them. Instead, you can see that the deep learning is the smallest of all. There is a reason. In machine learning, there are a lot of statistical algorithms which are there, and it contains majorly three type of algorithms, which is supervised, unsupervised, and your and the third one is your, what you will say, the concept of
Reinforce.
reinforcement learn. Yeah, the reinforcement learning as well. Basically, the three concepts comes in this, which is supervised, unsupervised, and the third one is reinforcement. These all are subset to your machine learning. Whereas the deep learning, in this case, you'll have, obviously you have the subset of supervised and unsupervised, but the number of algorithms are quite limited. Reason is that they're all different combination of neural networks. Okay, we'll have the discussion about what is neural network and what are the different combinations, like we are talking about here. Supervised, again in this case also we'll have supervised and unsupervised, and we'll talk about the list of the algorithms under these two sections. Okay, so this is how your deep learning is. Now let's talk about what exactly is deep learning and how it is different from the machine learning. What type of problem statements we should apply on deep learning, and what type of problem we should apply on machine learning. So when you are having some data sets will be there, which will be like some problem statements will be there where you need your accuracy or efficiency to be very high. In that case, your deep learning concept will be a suitable one. Reason is that it learns quite slowly, and the way it learns is through the help of neural network, which helps to gain the knowledge much more better in a much more better way as compared to machine learning. So that has been observed that in many of the circumstances where the problem statement includes images and signals, uh, some complex data set, deep learning has outperformed machine learning in terms of the performances, in terms of the efficiency as well. So that's where exactly the application of deep learning will come. But obviously we don't apply deep learning everywhere. The reason is that it comes with a cost of a lot of resources are used. So if you will compare in machine learning, less resources will be used and a less amount of data as compared to DL, less amount of data will be used. And we expect our data to be simplified in this case. And mostly if you have got data in terms of files in your records form or file form, then machine learning is a good take. But when it comes to deep learning, we talk about the complex data set. So first of all, resources requirement will be high in this case. You will talk about that you should have GPUs and TPUs in this. So high requirement of resources are there to solve this type of problem. Next, we will require large amount of data. Comparatively, you need a large amount of data in this case. So large number of resources, large amount of data, and this can be applied to complex data sets. The comparison between AI and machine learning, you can see here. I have already said few words about this. Is the main comparison. You can see that artificial intelligence aims to increase the chance of success. All it seeks is for success and not for the accuracy. Whereas in this case, the major idea behind applying machine learning is that you will be having the data set, and with that data set, you will care about all you care about is the high accuracy. This is how your performance will be measured. Okay. Next, artificial intelligence is something where the decision making is common, whereas machine learning allows system to learn new things from the data. This is one of those concepts which should be data driven. It makes a decision making with the help of data. Whereas in artificial intelligence, you build solutions which makes decisions. So many a times you will not have the data. So like I said for the machine learning, that you have to first train your algorithm and then you have to check the efficiency of that algorithm before even you apply it. But that is not true for the artificial intelligence, because in this case the intelligence can be gained from the environment, and then slowly and steadily. Is this today the voice issues, why it is coming up? I mean, everybody is saying the mic is already allowed from my side. I think at your end the attendees permissions has been already been given. Even automatically adjust mic, everything is given from my side. How it is going on with the other participants? It says that no, I am loud, but I think the part, this is like three or four people have are saying that my voice is not audible or something like that. I mean, I don't think so. It is from my end, but all right. So I'm moving to the next part then. So this was the comparison between artificial and machine learning. Remember one thing that yeah, I was speaking about something on AI basis. I was saying that in artificial intelligence, training and testing will be not always mandatory. Okay. In artificial intelligence, training and testing is not always, it won't be always mandatory. What you can do is you can basically take the data from the environment, check the performances, or sometimes what happens is the AI always keep on learning throughout its life. Deep learning is subset to machine learning. The difference is that the deep learning inspired by the functionality of our brain cells, which is known as neurons, which led to the concept of artificial neural network. So let's discuss that. This is a particular subset of machine learning algorithm that is inspired by functionality of our human brain cells. So I can say that deep learning neurons. Rest all is similar to machine learning. It also needs to go through the training. It also needs to go through the testing process. Once they are done, then only it can move to the. This is the basic structure of a deep learning neural network, or you can say the deep learning neuron. In this case, you can observe that we are having three layers. The first layer is your input layer. Second layer is called as your hidden layer, and the third and the last layer is called as your output layer. Now, in real world practice, hidden layer can be many. input layer will be always connected to all the inputs. A basic structure of a neuron, I will discuss it. As of now, understand that a neuron will be always giving you output in terms of many to one. Like it will grab multiple inputs. So here, say the first neuron is taking all the input from all three, and what it does is it basically takes multiple inputs from everywhere. Okay, basically it will take from all these three. You can understand it like this. You can basically understand in this way that your inputs will be fed to the first layer, then we are getting a single output which is getting transferred to all the hidden layers again. So remember that one input is going to all the outputs. Better I'll go to my whiteboard and I'll explain you there how exactly it works. Here it won't be possible. So let's go to my whiteboard and let me explain you there. I'm starting with the concept of my deep learning. So let's go ahead. Let's try to understand first what happens in traditional programming language. How a traditional programming method from your machine learning. Let's have a comparison between this and deep learning, or you can also call it as machine learning, as we know that. So here what will happen is we'll have the data set of the data, and we'll also have the, you have to write the program. In a traditional method, the programmer have to write the data and the program both. Here program means nothing but the rule or the logic. This has to be written by the human being. We have the let's write here about the traditional programming method. To my traditional programming, I will feed my data and the logic, and will get the output as, will get the result
The
as
whiteboard
an
is
output.
not visible. Excuse me, sir. Whiteboard is not visible at all.
I think you need to share it.
Now it will be visible. So I was writing this, that will have a data and the program. Program here means the rules or the logic which will be capable enough to solve the, or to get the output. This is the traditional approach where the rules and everything has to be written by the human being. So human intervention is required here.
Sorry to interrupt you, sir, but still, whiteboard is not visible.
It may be due to the network slowness. You can
Yeah,
wait
yeah.
for a few minutes.
Yeah, few of them are. I think so, they are in Bluetooth network. I'm able to see it.
If you are in good network, it will come quick, otherwise it will take some time. Okay, let's say for example I wanted to write a logic to categorize if person is walking, running, or cycling. So let's begin here. If the speed is smaller than equals to 4 kilometers, this is how the logic will work. Hence, the statement has to be written by the human being. In this case, you can see if the speed is smaller than 4 kilometer, will print. If it is a Python code, I have to write print statement, and print will be person is walking. This is the first condition. Second, speed of a person is smaller than equals to 12 kilometer. Sorry, if the speed is smaller than equals to 4 kilometer per hour, will print. Second condition I'm right, say that the person is walking. Next, if speed is smaller than equals to 12 kilometer, will print that person is running. In the end, if the speed is greater than 12 kilometer, will say that, will print it as person is. This is how the categories are made. First category, second, and third. Now if I'll go to my next part, we'll have the image here. So let's take some image data, and or let's have some other similar type of data like videos, etc. So if we are having this type of scenario, what we can do is we can simply extract out the x and y from this. That is, the machine learning approach or the deep learning approach will be that you will take input and output, or the data and the output, and you will feed it to your machine learning programming. We'll write here machine learning, deep learning programming. You feed it the data, you feed, and what it will return you is known as the program. And as I said earlier, program is nothing but it is the, here are my logics, which include if the speed is smaller than equals to 4 kilometer. These logics been formed by the human being first, and then later this was replaced by uh, these type of programs, as you can observe here in this case. Okay, now let's go to the next part. Let's take the medical data, medical images. So I'll take some data set here. Let me take images from here. Let's say I'm having brain tumor image, how my brain tumor image will look like. Now, if I'll convert the brain tumor MRI data into the RGB form. So it will appear like this. So we'll have on the other side the three values. So first I'll take it as red color, then we'll take it as okay, even I'll start from the first red RGB. Every image data will be appeared like this, and it will be in terms of metrics, by the way. It will be a matrix. This is how your matrix will be formed. This is how your matrix will be created. To each of this box will be numbers which will range from 0 to 255. To each of this square box will have the value or number that will range from 0 to 255. There we go. We are having red color, green color, blue color. So let's start here. These are your color pixels. Okay. Now, what happens in machine learning approach is that externally you have to do a process of feature extraction. Basically, you need to extract those pixels and prepare the data, which will be helping in making our predictions better. So feature extraction is an external step in machine learning. And then after preparing the data from the raw image data, you will apply this to your chosen algorithm, and then in the end you will make the predictions. Whereas if you will look at here in deep learning, in that case, from this raw input image data, let's assume that this is X. This will be fed to your neuron layer number 1. This is my neuron layer number 1. We'll start. Okay, now you can call these two as hidden layers, and this is your input layer. Okay. Now, what is important here is that in machine learning, feature extraction has to be done by the human being, that is the coder, and it is an external step. Whereas here, extracting the features has to be done by, as an assume that this is my X value, and from the X, when it is fed to your first layer or called as your input layer, it will return you X dash. Now this output from this will be now sent to the next layer. Okay, now in this case multiple neurons will be there. I have already discussed about the structure. So assume that multiple neurons are there. So this will return you X double dash, and this X double dash will go to through my next hidden layer, and it will return you X triple dash, and finally you will have the predicted output for this. This is how your basic deep learning concepts work. Any questions, any queries here?
Is there any rule that says how many neurons must be there in a layer, and how many layers can be there
That
between
part,
input and output?
that part I will discuss when I will discuss this in. Okay, it seems to be there are no queries now. So let's just move ahead to the next part.
Hello, sir. Sorry to interrupt you. I was unable to mute, so talking from someone else's machine. I didn't get actually what you wanted to show in the above figure, that the feature extraction is part of both, but in machine learning it is external and in deep learning it is internal, is it?
Yes.
And how is the relation? I missed that part. Brain MRI image is related to RGB. That relation I didn't get actually.
This is nothing but this is just a representation of how an image will be represented. You see this image like this, but for computers it is like this. That it will be a matrix. It will be a 3D matrix, three-dimensional data. It will be, and each square box will be having color range between 0 to 255, which will indicate 1 pixel.
Okay. Got it. Thanks.
So that's what the data is, which we need to be fed to either the machine learning algorithm or to the deep learning neural networks.
Excuse me, sir.
Yeah.
Yes, so you have very well explained the difference between deep learning and the machine learning with this example. Kindly explain this image by artificial intelligence also, so that I can make the difference between AI, ML, and DL. How
In
the output
artificial,
is.
see, artificial intelligence, in that the thing is that you need to understand that in to build the artificial intelligence, you need to be dependent on again deep learning and machine learning. Okay, it is
Okay,
no different. I mean, if you will see the difference is in the application side. That is,
okay,
when let's say I'm right now making a prediction for this brain MRI with the help of deep learning. Now, let's say I will make this one so advanced that it will be able to scan every brain MRI and it will able to make decisions about if the person should be. Now, I not only just that, I'm making the decision whether the person need immediate cure or what type of cure it will be needed. That will be an AI. What type of medications it should take. So in this case,
okay,
we are replacing a decision making of the doctors by a machine. That will be the AI thing. But if you are simply making prediction if a person is having tumor or not, this is
deep learning.
will be your application of machine learning and deep learning.
Okay. It is generalized form. Yes, AI
It will be decision making. When
decision
wherever
making.
you see an AI, it will be decision making thing. If decision are made, then it is AI. If predictions are made, then it is deep learning or machine learning.
Okay, sir. Thank you.
Sir, I have a question, sir.
Yeah.
So in this case, apart from prediction, if classification is also done, classification alone is done, it comes under machine learning or deep learning. Am I right, sir?
Classification is also part of predictions only.
Okay. Okay. Whenever the decision is to be taken, and if the system is able to make the decision on its own, then we
Hmm.
call it as AI.
Correct.
Yeah. Thank you, sir.
In that
Thank you.
it will be giving you solutions, etc.,
Yeah.
etc. Many
Thank
things.
you, sir.
Okay,
Thank you.
let's talk about the deep learning and how it is divided. First of all, every deep learning base is neural networks. Okay, and now I will talk about the different type of deep learning. So this is majorly divided into two parts. One is called as supervised, the other one is called as unsupervised. Supervised and unsupervised. Now let's divide it into two parts here. We'll have the target or label. When your target or label is equals to yes, you will say that it is supervised. When you don't have the available target, so there is no target or there is no label in your data set, then the problem statement is unsupervised. Simple. If you have got the y and you are trying to establish a relationship between y and y maps to f of x, this is supervised. When you just have the f of x and with the help of f of x you try to perform things like segmentation or clustering, like grouping in the on the basis of similarities, then you don't have the target but you are just using the features or x value to basically perform the segmentation part or the clustering part, which will be considered as your unsupervised learning. Supervised is further categorized into two parts. It is continuous, it is called as regression. When your target value is a categorical value, then it is considered to be classification. Now let's talk about the applications of regression and application of classification. So In regression, the example will be, let's say that you have something called as, what you will say, okay, predict. You are trying to predict insurance, medical insurance cost. If you wanted to predict that with certain features, what will be the cost of medical insurance that one has to pay? This is your first part. Next, we'll have ECG data. Okay, or you can have classification, right? So we can talk about things like we have the face mask images, and using that I can basically create a model which can classify if a person is wearing mask or not. Let's talk about the unsupervised learning. In case of unsupervised learning, we are talking about concepts of autoencoders. Now there could be many such examples to solve what are the algorithms. Yeah, let's talk about the algorithms, right? Now there are some common algorithms which can solve both. Okay, like here we are able to classify if a person is wearing a mask or not. Similarly, the same image can, same algorithm, after making few changes, can be also applied to the regression data where the target will be continuous. So examples: number one, artificial neural network, or you can just simply say dense neural network. Dense neural network, or call it as DNN. B, convolutional neural network, call it as CNN. Third, recurrent neural network. Recurrent neural network. In part of recurrent neural network, there is a subset called as LSTM, which is also part of this. Call it as long short term memory. There is one more algorithm, YOLO, quite a famous algorithm which is used in object detection. YOLO is for object detection. Now let's move to the next part, unsupervised learning. Autoencoders. Let's start with our autoencoders thing. This is used for removing noise from image data. Okay. If you have got noisy images and you wanted to eliminate that noise, then it will be done by the autoencoders. It will be done by the autoencoders. Next, dimensionality reduction. Dimensionality reduction is also done by your unsupervised learning. Is also concept of your unsupervised learning. Next, restricted Boltzmann machine, call it as RBM. This is used to build a recommendation engine. This is used to build your recommendation engine algorithm unit. This is done by image segmentation. Concept of your unit is also one of the algorithm quite famously used if you wanted to do the image segmentation. Okay, if you don't know the segmentation is basically to highlight the specific region Okay, so these are all your things about the different type of deep learning, and in this I think most of the concepts will be discussed. Like we will discuss about DNN, we will talk about the CNN, we will talk about the UNet. I think these three will be discussed. We'll talk about the concept of classification more, because the types of data that we'll be dealing with the images, and in images, um, majority of the problem statements will be for classification. So that's how the things will go. That was your introduction type. We are done with our basic introduction. If you have got any questions, you can ask, or else we'll take our things to the programming part. And in the programming, we'll start with the Python programming first.
Excuse me, sir.
Yeah,
This,
listening.
this unsupervised learning autoencoders dimensionally reduction is also in neural networks, because I have done this in
Yeah,
data mining.
autoencoder is not machine learning. Autoencoders are neural networks.
Neural networks. These all are for neural networks, all these things.
Mm-hmm.
Okay, sir.
Dimensionality reduction can be also done through the help of autoencoders. And removing the noise also can be done through the help of autoencoders. Image segmentation is done by the unit, and restricted Boltzmann machine is there, which is used for recommendation engines.
Recommendation engines. Okay, sir. Thank you. Thank you.
Sir, I have a question, sir.
Yeah, yeah.
Yeah, sir. Whatever
Yes,
you have said is
yes.
all are structures, right? Autoencoder, Boltzmann machine, all are different types of networks that can be used.
Different type of
Unsupervised.
neural network structures. Hmm.
Yeah, but what is the algorithm, sir? K-mean clustering, all those things will come into picture. Like in supervised, you mentioned about the algorithm names, like DNN, all, but
These are
DNN
names
things.
only. Autoencoders are name only. Autoencoder is a name. Restricted Boltzmann machine, which uses the concept of
All,
Boltzmann
all,
machine.
all are structures only. All are like CNN, DNN, they are all structures only, right, sir?
They are
Like,
considered to be the algorithm names, right?
okay, sir, fine, thank you.
They are considered to be names which will be having different concepts and different structures. Their base structure will be similar to the dense neural network.
Okay, sir, the doubt is in supervised learning, as far as ANN is concerned, we have an algorithm called, in supervised, for example, or semi-supervised, we say KNN or LVQ neural
Those are
network.
machine learning.
That's a machine learning. Okay, sir, fine. Here, network names are also called as algorithm names.
This is the algorithm.
Okay, sir, fine. Thank
This is not a network. It is called as neural network, right? Neural network will remain common to all the network, because their base structure is designed on the basis of neurons. So that's why the name is written as neural network.
you.
The
Okay,
structures are
so
dense, convolutional, recurrent. These
neural
are
net.
the algorithm names.
Okay, sir, okay. Yeah.
Okay. Any other doubt?
So which is the this algorithm which you have stated here, dense convolution and recurrent neural network? Where exactly it can be understood deeper? Where which to apply where? Means example.
See, technically saying, I can apply to all the problem statement, all these algorithms, but the way they are, you know, working or functioning, on the basis of that, they have their some specific area of expertise. But that has to be like, I mean, I cannot say that I cannot apply CNN to a normal data set like a CSV file. I can apply that, but it has been understood that the CNN, when you apply it to the concept of images and video type of data, then it performs better than the other neural networks.
Yes, sir.
But that doesn't mean that I cannot apply CNN to solve a CSV file. Like that,
Uh,
dense neural network I can apply to a CSV files, or basically I'm talking about the file type data. Okay, now recurrent neural network I can apply to many examples like image tagging,
okay.
caption generation, okay, generating text, recommending text, in fact, on the basis of the past history, time series.
Okay.
These are the applications where restricted neural network are good, but that doesn't mean I cannot apply recurrent neural network to the images data. I can apply it.
Okay, sir.
Sorry, sir. One more thing. What is the application of dimensionally reduction? I know what is dimensional reduction, but what is the application?
Features will be when you will be having lot of features, and you wanted to extract out the important features from there. That is how the application will be there. Like we had got 10 features, and from those 10 features, you wanted to have just 3 features or 4 features. So
Yes, etc.
what you are doing? You are doing dimensionality reduction in that without losing the importance of all the features. You are superimposing, or you are trying to transform those 10 features into 3 features.
Okay.
So
Okay.
dimensionality is reduced, but without losing the data. You're not losing the information,
Yeah,
because
yeah,
all
yeah, yeah.
your 10 features informations has got transformed itself into 3 features information.
And this is unsupervised learning.
Correct. This is unsupervised only.
There's no classification. Okay, sir. Fine. Thank you.
Thank you, sir.
Okay, we are done with this. Let's take a short break, and after that, we'll start with the Python. No installation needed. We can use for today Google Colab. Uh, by the end of today's session, I will ask you to download the important package. In fact, let me just share with all